Today I'm going to show you how to graph linear equations in slope-intercept form, and we're going to do that just by plotting points. They're linear equations because when you plot the points and you draw a line through them, they actually create a straight line. Also, the exponent of this variable x is just a 1. All right. What I want to talk about first is the coordinate plane. All right. We have the x-axis, which is horizontal, and the y-axis, which goes up and down or vertical. The way I tell my kids to remember this is that your y's rise, or if you think about, if you make a capital Y value letter, the tail of the y goes up and down just like the y-axis, and your x-axis goes left to right. And if you run cross-country, you know that cross-country is xc, cross-country, and you always run left to right. So in the equation y equals mx plus b, we have m, which is the slope, and b, which is the y-intercept. All right. That's where my line, when I graph it, it'll go through this y-axis. Right. Slope, as you learned previously, is the same thing as rise over run. Right. And when you graph an equation, if you have a positive slope, so if this m value is positive, your line will go up and to the right. Right. If it's a negative slope, it'll go down and to the right. If it's a very large number, say like a 7 or 12 or 13, it's going to get very, very steep very, very quickly. If it's, suppose, like a small number less than 1, like a fraction like 1/5, it's going to be very, very flat. Right? So there are just two things to think about, a couple things to think about before you graph anything, just having an idea of what your line will look like. Right? So let's look at the equation y equals 2x plus 1. Right? Here we have 2, which is associated with the x. The value always associated with the x is your slope. My slope is a 2, and my y-intercept, or my b, is a 1. All right, you can write it as b is equal to 1. This number is also known as a constant. It's a constant because there's no variable attached to it. It will always be the same. Right? This 2 will change as x changes. As we plug different values in for x, 2 will get bigger or smaller. And the way we're going to graph this equation, y equals 2x plus 1, is by making we'll call it an input-output table or an xy table. I call it an input-output table because your x values are your input values. You take them and plug them into your equation, and whatever you get out is your y value. All right? It's also known as your x values are your domain, and your y values are your range. And to pick x values, you can pick any random numbers. It makes sense to pick numbers that are easily graphed. Don't pick numbers like -12 or 34. Pick numbers, I usually use a -2, -1, 0, 1, and 2. And it's good to pick a handful of numbers because you want to see that they fall in a straight line. If they don't, you should go back and check your work. And what we're going to do is we're going to take these values, this -2, and we're going to plug it in for x. And we'll take this -1, plug it in for x. And whatever we get on this side of the equation, that's where we're going to write over here on the right side. What I would suggest when you plug these values into your calculator is to use parentheses wherever you see an x. So if we have 2 times -2 plus 1, always use parentheses because it just makes things a lot easier, especially when you start dealing with exponents that aren't 1. All right. If we take 2 times -2, we get -4. -4 plus 1 is -3. So my output value for -2 is -3. And what we'll do is we'll take these other values and just replace this -2, and we'll complete our table. All right. So once we've completed our table, these numbers, they're just ordered pairs, and you're going to plot them like you would any other ordered pair. So -2, -3, you'll go -2 to the left 2, and down 3. For -1, -1, go to the left 1, and down 1. 0, 1, over 0, up 1, and over 1, up 3. You can kind of see these are taking the shape of a straight line. Over 2 and up 5. You can see these all fall into a straight line. And if you wanted to, you could, if you weren't sure, make a couple different x values and plug them in there and see if they form a straight line. And what we're going to do is we're going to take our ruler and draw a straight line through these points with double-ended arrows. Right. And it's important to understand that this line that I just drew, it goes into infinity in both directions. It represents every point, every ordered pair that I could plug into this equation and satisfy the equation, so it makes it work. So for example, this point right here is -4, -7. If I plugged -4 in for my x value, all right, and I computed this, I got -4 plus 2 plus 1, I should get a -7 for the y value, and I do. So this line represents all of those points. All right. Let's take a look at one last example. We have y equals -1/2 x, and we don't have a b. All right. If you ever see something like this, the only other possible option is that you have a 0. So your b is actually 0 in this case, which means that your line is going to go through the origin. That's your y-intercept. It goes through the origin. All right. My slope, m, is equal to, it's a -1/2. My b is 0. That's my y-intercept. With m equaling -1/2, put the negative sign with the top or put it with the bottom. Whatever you do, do not put it with both the top and the bottom, because you'll actually take your slope and make it positive by putting it with both the top and the bottom. So I always put it with the top, make it a -1 over a +2. And just like before, we're just going to make a table. All right. Now, because my x value is going to be multiplied by 1/2, I'm just going to use even numbers. So I'm going to use, let's say, -4, -2. I'm going to put 0 in there, and 2 and +4. And once again, I'm going to take these values and plug them in for x. And I'm going to use parentheses wherever I see my x value. +0. We don't actually have to write that +0. And a -1/2 times a -4 is a negative times a negative is a +2. All right, and so that's +2. I'm going to go through and complete the rest of this table. All right, I went through and completed the rest of the table, and I also plotted the points. And you can see that if I drew a line through these dots, it would definitely be going in a negative direction, going down and to the right. And also, you can see it's a little bit flatter than the previous graph. Remember, if I made that into a -1/3 or 1/4 or 1/5, this line would be even flatter and flatter, almost becoming perfectly horizontal. So what I'm going to do is draw a line through these points, put arrows on both ends, and we're done. All right? And once again, this line represents all of the ordered pairs that I could plug into this equation, and it would make it a true equation, or it would satisfy the equation.